sorry. Okay, this is section 5.4, logarithmic functions and models. So common logarithm means the base is a 10, okay? So which is the same as a log of 10 to the k, same as a k. So what is important is it's actually the exponent's k. So we need to know let's talk about the common logarithm first, okay? So domain is a 0 to infinity, and the range is now this times a negative infinity infinity. So in order to find the common log, this is what you need to know first, okay? So let's say your exponential function, which was f of x is a base of 10 to the x power, okay? And then I want to find the inverse function. So y equal to 10 to the x, okay? So these are the same still. But now, interchange of x and y. Now this is the inverse. So in order to find the inverse and then continuously, I need to solve for y, which is y equal to, because y is coming from the exponent, so we need to mention that. So the meaning of that, the value from the exponent is a log. And then base is 10 of the x. But base 10, you don't need to write it. You can just say log of x. Okay, so that's actually what it is. So whatever this one, and then you can just so this is the base of the 10. So base could be anything, but it's still positive, but not equal to 1. Alright, so common log is a positive number x denoted by the log of x, which is what I got here. And the log of x equal to k, which is x equal to 10 to k. So you can put the vice versa. So you can put the log of 10 same as a 1. And then log of 100 same as 2, 1,000, 3, 10,000, 4. 1/10 is negative 1. So it is all about the exponents, okay? So you can just see that all the exponents come out as a value of the log. Alrighty, now graph of the 10 to the x and then the inverse function of the log of x. So these two are the inverse, okay? And then as you notice, if the exponential function has a growth because 10 is a positive, 10 is greater than 1. But for the inverse, you can always use the point that is go to the interchange, right? So 0, 1, you found those 1, 0. And then another point you got here. And then this is always symmetric, the axis for the two inverse functions. So you'll see those functions, okay? So inverse property of the common log, which is the following the inverse property is a hold on the common log. So log of 10 to the x equal to x. So you always put out the exponent by itself. And also another rule is this is come out as x too. So when you need to simplify it, you just need to say that this log has a base of 10, but also the 10,000 is the same as 10 to the 4. Then you can always pull out the exponents. And then this one is a log of 10. 10, but 7 to the first power is 1, which is this equal to 0. And also this one, log of base 10, okay, and then 1/10 is the same as negative 1 power, which is negative 1. And then this is a log of 10, and then this is 100, but this is 100 is the same as 10 squared, right? So if you change to the rational exponents, it becomes 2/3. So equal to 2/3. And then log of 0, which is not, it's undefined. Okay, log of 0 is not possible. Alrighty. Then example 2, the number of the malaria death in the millions x year after the year 2000 can be modeled by d of x equal to 0.9 log of the 10 minus 2/5 of x. We want to evaluate the d of 5 by hand. Interpret the result here. D of 5, we just need to plug it in. 5 must be the year. 0.9 log, no parentheses, a log of 10 minus 2/5 of 5. And then this cancels out, so you got 0.9 log of 8, which is common as 0.81, which means in 2005, because 5 years after 2000, there were about 0.81 million deaths from the malaria in Africa. So, which means, yeah, that's the number that was, okay? So, which is getting less and less, right? And then now we can let's talk about the basis 2 design. So we were talking about base 10 for the common log, right? But now it could be the base 2, so 2, 2, 2, which is right here. And also this is also base represents, okay? So whatever number you plug it in, it come out as exponent, right? Do you see the match, right? So base of the 2 logarithm graph is going to be the increasing 2. So base 2, base E, now base is a E right now. So when you have a base of E, so log of base of E of the x, you can say ln x actually. So that's where ln coming from. So base is E right now, don't you see it as here? Base is E, which has come out as exponents too, okay? So you got the graph coming as this way too, because E is a positive, the greater one. And then logarithm with the base of a positive number, x denoted that we got the log base a of x is defined by this, and this is vice versa. So where a is a positive, not equal to 1, and then k is a real number, and then you got this one. It's called the common logs function with the base a. So we want to evaluate this one. So now, as you notice, as long as you can match the base to the whatever 81 is base of 3, and then we can pull out the exponent. So log of 3 of 81 is 3 to 4, right? So you can say equal to 4. For the other one, log of 4, but 64 is actually the 4 cube. So it's the same as 4 to the negative 3, which is equal to negative 3. Log base 4, 16 to 4 square equal to 2. And then this is, you can just say 0.67 because this E and the ln also take the E too. So it's not about cancellation though. And the most important thing the domain for the log is the next to the expression next to the log, x plus 1 always need to be positive, not even equal to 0. If it's a 0, is undefined. So solve for x, subtract 1. So that's it. So interval notation, you can say negative 1 to infinity. Same here too in the B. So x squared must be positive. But it's a quadratic, right? Remember? So solving quadratic inequality set as an equation. So, but this is only the 0 though. So when you use a 0 here, and then if you use a test point with a negative 1 and 1, plug it in, always true. So everything okay except the 0. So the domain will be all real number except the 0. The 0 makes undefined. The other number is fine. All right, inverse properties. The following inverse property holds for the logarithm base with the base a. So yeah, so as long as you match this and this with the log and the x comes out, and then same thing here too. This is a match and the x comes out too. And then the applying the inverse function always is symmetric with respect to the y equal to x. See here, whatever that is. So when you use that, this is equal to the pi, this equal to the 4x, and this equal to the 4.6. Very easy to answer. And then number 6, explain how to obtain the graph of g of negative 2 log of x from the f of log of x. So this table, so actually in here, use a 10. So I can't really use that much, so, but x must be a positive number, so I can use that. So I want to use the maybe 1/10 and then maybe 1 and then 10, okay, because that's the numbers I can find there. So if you use a 1/10 in here, log of 1/10, which is going to be negative 1, and then log of 1 equal to 0, log of 10 equal to 1, okay? So 1/10 is about here is negative 1, very close to 1, and then 0 and 10 becomes a 1. So your graph is this, okay? And then for this graph, you need to actually flip it, reflect it, and then go go to twice, stretching twice, right? This time. So as the -1 and then go to 1 and then stretching 2. So right here. But 0 just stays at 0. So 0 times negative is 0, right? So this is actually the 1. 1 times negative is a -2, right? So your graph of that, as a g function, going to be this. So stretching with the reflections. All right, we're going to solve for x for the 10 to the x power equal to 10,000. This is easy to do this, okay? So what do you do here? As a 4, so x must be equal to 4. But this one, the b, there's no way we can solve it by the letter a way, because 125 cannot be equal to 10 to the any power, right? So this time, I want to use the change of form, okay? So when you're looking for the exponential, exponents always equal to the log, because you need to mention the x is from the exponents, right? So you have to put the log. So that represents, so x represented, the log represented the x coming from the log, the exponents. And then base is a 10 of the 125, which is, this is the same as the log of 125. Okay, so, and then you can use a calculator if you want, okay? And then this is actually the same thing too. So we are solving for x from the exponent, and the log base is 10 of the 1 minus pi. But this time the 1 minus pi is actually less than 0, right? So that means it's undefined. Okay, all right, let's do the next problem, example 8. So example 8, we're solving for x, okay? So whatever number is not from the exponent, just make it nicely. So 10 to the 2x minus 3 equal to 12. And divide by 4, 10 to the 2x minus 3 equal to 3. And then we can change the exponent is the equal to log of base 10 of 3. And then we just need to solve for x. So add 3 both sides, which is, I said 2x equal to, I want to put 3 first. Log of 3, and then divide by 2. So x equal to this. So 3 plus log of 3 divided by 2. Use a calculator, approximately 1.739. Alright, solving for x, the same thing too. We are looking for the log of x, but this time actually we're going to change the exponential form. So exponential form, I always check the base. So 10 is a base and exponent is 2 equal to x. So x is 100. Base is 10, exponent is -1 equal to the x, which is x equal to 1/10. Base 10 to the 0.2 equal to the x. And then if you calculate it, it becomes 1.58, which is going to be x. All right, number 10. The solve 1/2 log of 2 minus x plus 1 equal to 3. So yeah, 1 both sides. Half of log 2 minus x equal to 2. Multiply 2 both sides to get log of 2 minus x equal to 4. Now change the exponential form. So base is 10 to the 4 equal to 2 minus x. 10,000, 2 minus x, and subtract 2 both sides. I got 9,998, which equal to negative x, and divided by -1. It should be the negative 9,998. Okay. Example 11. The table lists the number of the type insects are found in the Udon region with the various acres. Which is with that, and then this is what we have to find the value of the a and b, so that the f of x equal to a plus b log of x model this data. Then they use f to estimate the acres that might have 12 types of the insects. So I think I want to use this one and also this two. Okay, so yeah. A plus b we don't know yet, but log of 10. So f of 10 is 100. So a plus b log of 10 is 1. So we got the first equation. So now I'm going to use 100. You can use either one, right? B log of 100, which is 800. A plus And log of 100 is become 2, so 2b. Alright, and then I'm gonna multiply by this equation by -1. I got -500, -a minus b, add them up, 300 equal to b. Now the a is gonna be plugged in right here, so a is at 200. So your f of x, now the a is 200 plus 300 b to the log of x. Now plug it in 1200, which is a 200. Oh, the insects is a 200. Sorry about that. It's not the acres, okay? So insects is a 300. So that's not. So this is going to be 1200. And then 200 plus 300 log of x. And then we're looking for the acres, right? Okay, so subtract 200, which is a 1000. Which is a 300 log of x, divided by 300, I got 10 which is log of x, and then change the exponential form. So 10 to the 10 power, which equal to x, and this is about 2,154 acres. All right. The next page. Okay, so we are solving for the more equation here. So yeah, so easier to do, just do whatever. So 2 to the x is 1 over 2 to the 4. So 2 to the x is 2 to the -4. So you can say x is a -4. Okay, divide by 2 both sides. E to the x equal to 7 over 2. So in order to solve for x is actually the x equal to the log base e of 7 over 2. But log of e is same as ln. So use a calculator. Then it says 1.253. And then add 6 both sides to get 5 times 3 to the x power equal to 30. And divide by 5, it becomes the 6. And the x is a log, base is a 3 and 6 times. And then that's all. I haven't showed you how to change the base here. But if you have the calculator that has change the base as a 3, go ahead. And then you might get the decimal too. Solve this, change the exponentials. So you gotta be base is 6 to the exponent 3 equal to x, which is 216. Okay, that's easy. And then base is 3 to the -4x, and then this is same as 1 over 3 to 4. This is same as 1 over 3. And this is a base is e 6.2 power, which is equal to x, and then approximately 492.7, which is x. Divide by 2 both sides, a log of 2 to the x equal to 2. Oh, no, divide by 6 both sides. And then base of 2 squared to the x, and divide by 3, which is a 4. And divide by 3 both sides, x equal to 4. Alright, so that's all. It's not bad if you understand where's the logarithm coming from. Alright, thank you.